we're going to do correlation. What we're asking here now is whether or not carbon monoxide and tar are correlated, right? And what does it mean to be correlated? So what we're going to kind of think about is what's that relationship and how are these things related, right? Okay. So I'm looking at this and I'm going to say, okay, well, why correlation? Okay, why correlation? Let's consider what our two variables are. So our explanatory variable, the one that we've already tested, is our micrograms of tar. It's the amount of tar. Okay? And then our carbon monoxide, or excuse me, our response is going to be the CO. In, again, micrograms. Is CO, carbon monoxide, in micrograms. Notice that this is a quantitative variable, and this is a quantitative variable. They're both quantitative, okay? So this is Q to Q, right? That's our comparison, hence why it means correlation. Correlation is what we're going to use for a quantitative to quantitative relationship, okay? So Q to Q, all right? Now, I'm going to go back in, I'm going to go back to StatCrunch, and I'm going to go now to cigarette correlation. It's right above cigarette. Cigarette correlation, click. Now what you'll notice, by the way, this thing here is just simply nicotine. What I've done here is I've actually pulled out which cigarette they came from, and I'm just writing up, right? I just put in all the tars, and I match them with their corresponding carbon monoxide levels, okay? All of the tars with the carbon monoxide levels, and they are paired. So like a matched pairs, with a correlation, we have to have them paired. But they're different variables. In the case of, say, for example, the matched pairs, remember, both were attention, or like the number of seconds, right? In this case, they're different variables, right? That tells me correlation. I've got to correlate. Excuse me. Okay. So, right, I'm going to go in here, and this is a little different from a test. This is actually more of observational. We're not actually getting a yes/no. We kind of are, but we're kind of not. What we're going to look at, the important things that we want to look at here, right? So important things, and so consequently, you can put these into your notes as you're working, right? Watch the videos that we have on here. They're also inside of the book. They've got a lot of this information, and I'll send you some. I have some videos of my own too. Okay. So what are we looking for? We're looking for the direction of the correlation. So here are important ideas. We're looking for the direction of the correlation. We're looking for the strength of the correlation. And we're looking for something called linearity, right? And this is going to tell us things about our correlation. How well related are they? Okay? Direction, strength, and linearity. Now, so the direction tells me whether or not, right, as X goes up, does Y go up or down? So as we increase our explanatory variable, X, what happens to Y? Okay? Does Y, sorry, that's barely readable. Does Y go up or down? Right? Strength is literally how strongly related, how close to the regression line is our data. So when we look at our data, we're actually it generates a regression line, and we just want to know how close is our data to the regression line. Okay? And then linearity is, what's the shape of the regression? What's the shape of the pattern? Okay, so what's the shape of the pattern, right? Okay. So, right, so we've got these important direction, strength, linearity. So let's take a look at this, and let's talk about what are the things that actually tell us those three things, okay? So we're going to start out, we're going to have a graph. I'm going to click on my graph, And because it's Q to Q, right? And then we're looking at correlation. The graph that we use is the scatter plot. The scatter plot has an x-axis and a y-axis. The x-axis is our variable, which was tar. And our y variable was our carbon monoxide. Okay? Right? We wanted to know whether or not those two are statistically related. So the question that we're essentially asking is, as tar increases, what happens to carbon monoxide? That's essentially the question that we want to answer. Okay? Then I'm just going to go in and I'm going to put in my x-axis label, okay, which is tar, my y-axis label, which is carbon monoxide, CO. And then this is called the scatter plot of tar versus carbon monoxide. Or actually, we'll go the other way around. Make sure that your x-axis label, by the way, is your explanatory variable. Your y-axis y-axis label is your response variable. Then we're going to go compute. And there we go. So there it is. Ta-da! Okay. Does it look like there's a pattern? Does it look linear? Okay. Close. Okay. Now here's a question for you. If I said, as tar increases, what happens to carbon monoxide? It increases. Can you guys see that? As tar goes up, what it means to increase, it means to go along the increase, like get larger in that direction, right? Okay. And then larger in this direction. It means exactly what you think it means. It's not trickery, right? So yeah, and so what we'd say is this is a positive correlation, right? Or at least appears to have a positive correlation, okay? And so I go in here and I'm like, okay, cool. Not that one, I wanna go to this one. I'm gonna draw my scatter plot, that's my graph. Okay, cool, there we go. So, what I can kind of do, I kind of imagine, that's kind of my regression line, right? This is basically my regression line, and everybody can pretty much do that. It may not be exactly the same as mine, but you get a pretty good sense. Nobody's going to make that negative, I promise you, unless you've got a processing disorder, right? Unless you are a person with a processing disorder, visual processing disorder. Well, it could be auditory, like if you heard the exact opposite. Okay, basically, right, okay, basically positive correlation, okay? And pretty much it looks linear. I mean, it does a little bit of what we call a quadratic, where it kind of curves, but it doesn't really, right? It basically is linear, right? To kind of give you a sense, this would be, if it did something like this, that's quadratic. Quadratic means like it's parabola. This is what's called an exponential, okay, right? That's an exponential. It's neither of those. It's not that. Clearly not that. It basically looks linear. Everybody understand that? All right, cool. All right, so we start with the scatter plot. The scatter plot gives us some information about this relationship. Now, next up, what I'm going to do next is I'm going to say, okay, well, you know what? A graph ain't enough. What I need to do is I really need to get some statistics here. So I'm going to go into regression, and I'm going to click on simple linear regression. I got my x variable, tar, my y variable, carbon monoxide, okay? I'm not going to, at least for the purposes of this class, we're not going to look at the hypothesis tests. Instead, what we're going to do, we got the fitted line plot, right? Okay, just quickly, I'll do tar as my x variable, carbon monoxide. Tar versus carbon monoxide. Call it that, doesn't matter. All right. Then I compute. So you're like, hey, I've got to notice that I do still have p-values here. And if you want to ask which one's the hypothesis testing one, it's the slope one. Basically what the slope says is that our slope is statistically significantly different from 0, right? A 0 slope is it's flat. That's the mean. It's an average marker. It's not that. It's clearly not that. In fact, our estimate for our slope is 0.39, okay? Now, what I'm really concerned with is these things here, okay? At least for the purposes of what we're going to be talking about. It's those ones, and so it's the correlation coefficient, okay? And what's called our coefficient of determination or a variation, all right? So the correlation coefficient, okay, this tells me the strength and direction. So it gives me the strength and direction of my correlation. So what I noticed there is that I got a correlation coefficient of 0.587, okay? First, let's talk about its direction, okay? Positive correlation, positive R, is a positive correlation, okay? A negative R is a negative correlation. Let's catch that. So not only can we find that inside of the scatter plot, we also get it from R. R tells me if it's positive or negative. If R is positive, it's a positive correlation. If R is negative, it's a negative correlation, right? And then I get my strength. Okay, the strength of my correlation. And so here's how it goes. It's going to be in the absolute value of R, okay? Meaning make R positive, all right? If R is from 0 to 0.5, well, 0 is what we call no correlation. So anything really close to 0 is going to be no correlation. 0 to 0.5 is what's called a weak correlation. The next grouping actually is kind of up in the air, but let's say we're going to do 0.5 to 0.8. Okay, 0.5 to 0.8 is what's called moderately strong. Okay, and then 0.8 to 1 is considered to be strong. So, in case you want thresholds, them's the thresholds. Okay, that's how strong the correlation is. All right, and what does it tell us? That's the more important thing. Okay, sorry about that. What does it tell us? So I look here, I have my R squared, and that tells me that I have a positive, moderately strong correlation, right? So what that's saying is that I can be reasonably certain that as tar increases, carbon monoxide is going to increase, right? And they kind of increase in lockstep. If it had a correlation of 1, that means that as one went up by whatever amount it went, the other one would go up by the same exact amount. That's a correlation of 1, and then everything does it the same, right? It would be the same for every single one. Totally and completely predictable. This one is just in general kind of predictable, right? Mostly predictable. And in fact, it might actually tell us that if I can reduce my tar levels, I would probably be able to reduce my carbon monoxide levels as well, because they kind of go together, all right? Or pretty closely together. Would it be as strong as if I had a correlation of 0.9? No. Correlation of 0.9 is literally the two come together, right? Okay. So for example, smoking cigarettes and getting cancer. They're in lockstep, right? Okay. You smoke enough, right? We know that your risk of getting cancer goes up as much as you smoke. You follow me? Right? That's correlation-wise, that's exactly right. Right? Okay. Now, a couple of things, just a quick piece of information that's also really important. Correlation does not imply causation, meaning that it is only one part Okay? Only one part of the causative chain. There are two other parts. What are the two other parts? Well, I got to go study that. The two other parts were that the explanatory variable occurs before the response variable, and in the absence of the explanatory variable, the response variable doesn't change. But correlation at the very least gives us the two happen together. They show up together statistically. Okay? So that's my little mini thing on regression. All right? And we are finito. Questions on that?